Which expression is correctly representing the loss of energy during a given process? It's given in the question. Two disks which is having a same moment of inertia rotating about their regular axis passing through center and perpendicular to the plane of disk with angular velocity omega 1 and omega 2, and they are brought into contact and coinciding with the axis of rotation as well. It's known that during a given process, there will be some loss of energy due to friction as they are trying to reach a common angular velocity. So here we can calculate the expression by using a kinetic energy formula. It's known that the initial kinetic energy of a two disk can be written as EI is equal half I omega 1 square plus half I omega 2 square. So before writing the expression for final energy, we have to know about the angular moment. It's known that after the disks are brought into contact, they will rotate with a common angular velocity. So we can take the angular velocity as omega f. And the omega f, the final angular velocity will be equal to omega 1 plus omega 2 divided by 2. So here we can write the final energy will be equal to I times omega 1 plus omega 2 divided by 2 whole power 2. So here we can write this as I divided by 4 omega 1 plus omega 2 whole square. So this is our final energy value. So the energy lost is nothing but the difference between initial and final energy, right? So here the energy loss will be equal to energy initial minus energy final. So when we are calculating the difference, it will be equal to 1 over 4 I times omega 1 minus omega 2 whole power 2. So the correct answer for the question is option A here.